Okay, so I'm going to throw a little bit of a spanner in the works here. So I've spent most of my life as a mathematical person thinking about space-filling curves. And space-filling curves, as I write papers and so forth, they take up enormous amounts of space in a PDF file, even though they are procedural objects that can be compressed down to incredibly by 1,000 to 1 if you draw them algorithmically. So in the course of starting to use TeX, which I started to use it about 10 years ago, even though I've been very familiar with the TeX world since the very beginning, I discovered that I just didn't like using TeX. And these PDF files are blowing up and they don't compress. So for instance, here is a space-filling curve. That's a PDF file. It's 12 megabytes. It has 4 million line segments in it, and it's resolution-independent PDF. So I can go in and actually see the actual line segments that are being drawn. I want to put this into a paper, but I want to put it into a book that people can browse and understand and play with, but I can't do that in a PDF. So I said to myself, I don't like TeX, and I need to do this. I like what TeX does. I like the math typesetting. I like the the English the text typesetting. And since long ago I implemented a PostScript interpreter, and since long ago I got interested in languages, I said to myself, why can't I just rewrite this? Now, either I'm an idiot or I'm a really smart guy, but that's what I said. So I know Don Knuth. I met him in '81. I meet him regularly at conferences. And the first time I met him, I wanted to talk to him about space-filling curves because I was working as an illustrator for Benoit Mandelbrot at IBM Research. So I went out to meet Don Knuth, and I wanted to show him all these pictures of space-filling curves, and all he wanted to do was talk about typesetting in 1981, and I didn't understand it. Anyway, so be that as it may, in 2009 I decided I was going to rewrite TeX. So I'm going to say some things that are provocative. That's okay, tell me I'm wrong. But as an outsider coming to it late in the game, I just found everything in the TeX world was making my head explode. There's just too much complexity. There's all these versions, there's different formats, there's different this, that, the other. Somebody tried to rewrite it in Java and that never worked. And there's all these fonts, and there's OpenType, and there's these things called TFM, and there's encodings, and it's complex, messy, confusing. Is there any way to unify it and simplify it? And the answer is no, there isn't, without a complete rewrite of the core TeX engine. That's my opinion as a person who's been writing software for 40 years, as a C programmer, as a person who has had my own product that I've sold for years to classic Mac programmers, which you might have heard of, called Resourcerer. It was a replacement for the binary data structure editor that Apple used to distribute. So the thing that came to my mind was in Minority Report, which is a short story by Philip K. Dick, there's there's the mutants that are called precogs, and they have this special ESP power. And so this is the description in Wikipedia. The precogs sit in a room that's perpetually in half darkness, constantly talking to themselves, nonsense to themselves that is incoherent until it is analyzed by a computer and converted into predictions of the future. This information is assembled by the computer into the form of symbols before being transcribed onto conventional punch cards that are ejected into various coded slots. Doesn't that sound like fonts to you? Precogs are kept in a rigid position by metal bands, clamps, and wiring that keep them attached to special high-back chairs. Their physical needs are taken care of automatically. Well, I feel that TeX source base is like a software precog. Okay, just replace predictions of the future with high-quality automated typesetting in the previous quote, and TeX source is focused on and fabulously accomplished the one thing. It's depended on by an important segment of society, but in other respects, it seems kind of foreign, useless. It's written and protected by this thing called a web, and it's intubated with tangled shell scripts, and it's barely alive except by the grace of Web2C, life support software, and it's nursed by makefile minions and Unix wizards, and every once in a while by the Grand Wizard. And the image that comes to my mind is a prehistoric software insect that's caught in, not a web, but a big glob of clear amber. And you can look in and you can see how beautiful it is, and you can understand sort of what it is, but it's it's a fossil. It's not living, it's not an adaptable piece of software. And the reason is because software is not literature. Software is software, and my goal here is to tell you what I'm doing, at least personally, to invert the world that you guys are used to. So, but the only way to do it is to rewrite TeX from scratch. So in 2009, I sat down and I sat down with Don, actually at a conference, and I asked him what advice he'd give. He told me, go for it, good luck. You know, it's great. He had no problem with anybody trying to rewrite TeX. It's only the one error he thought that he wished that he hadn't made. And then he said, prepare yourself. It's going to take you 5 years. I said, oh, no, that can't be right. The U.S. taxpayer has already paid millions of dollars for him to figure this stuff out. I don't have to figure that out. These are, platonic algorithms that have been given out to the public domain. I just need to code it, right? It should only take me 2 years. So if I had believed him, I wouldn't have started. But just for the record, to get where I am now is about 4 person years of work. So what I've written is a library. It's called JSBox. It does not stand for JavaScript. It stands for Johann Sebastian. It's a personal joke. It's not what I'm going to eventually call it, but I needed a code name. So there it is. So I've worked on it double full time. I've stopped working on it for months on end, but I'm going to show you where I've gotten to. It's not TeX. It's a TeX language compatible engine. And automated translation of text code just won't work. You gotta bite the bullet. You gotta do the right thing. You gotta rewrite it from scratch. My philosophy is not Don's philosophy. Don's philosophy is to squash all redundancy and space and time out of his code to make it into, perfect example of algorithmicity. But that's not what software is necessarily. Software needs to have redundancy in it. You need to manage fragility, and you need to make it adaptable. And I want, of course, to make it as simple, understandable, usable, and portable as possible. And I've read, you or Nelson Beebe, right? Yeah. I've read your paper that you wrote a while back, and about the good things that went into TeX and some of the bad things. And I used a lot of that as well as some of my own ideas to enhance what I was doing to solve these problems. Well, what are TeX flaws? The most important flaw that TeX suffers from is that it's a program. It's a command line program, the way things are now. So I've solved that by implementing this as a library for any client program to use. The library instantiates one or more TeX language interpreters as an object in the memory space of its client program. Interpreters can be configurable at runtime to be at various compatibility levels. And the client program mediates between each interpreter and the user and the system. The library is 100% system agnostic. It does not know what standard I/O is. It does not do any memory allocation or file I/O. All of that is sluiced through a single callback subroutine that the client installs in the interpreter so that the interpreter can talk to the client and so that the client can do those system level services for the interpreter. So that means that the interpreter is completely sandboxable in a virtual way. It's not sandboxable in the virtual memory way, but the client has complete access and can manage all of the interpreter's interactions with the outside world. Another thing about this is that the interpreter is instantiated independent of whether a job is done or not. That solves a lot of other problems. Another problem with TeX, and this is a flaw in TeX that I consider a tragic flaw, to use a literate piece of analysis, and that is that it's written in web. And for the in literate programming paradigm circa 1983, and Pascal, which is almost a dead language. So my solution is to write this library in pedal-to-metal portable C. It's compilable under both 32-bit and 64-bit architectures. It's been compiled under both GCC and CLang. There are no dependencies on other software. It's about 100,000 lines of code, and half of that is English paragraphs. So I'm a firm believer in total documentation. And my next talk is going to explain about how that works out. I don't use web or C-web. I instead have, I created my own sort of syntax, visual syntax in my comments without actually having any software to deal with it. And after I did that, I wrote another program called Literacy, which I'll talk about next after the break, to actually typeset the code into a book form. It's 2,100 pages long. It's currently implemented as one C file with 2 header files, and one of those header files is because I'm hedging my bets. And runtime link testing is negligible, and it can be incorporated into any program that can call a C subroutine like C, C++, Objective-C, Python, and as of a couple of weeks ago, I heard Swift. So the next problem is formats. Formats are a form of non-transparent caching, and they are an unnecessary optimization due to the fact that TeX is a program. And they create modes that harm users and complicate TeX support. And I think that the language itself should have a primitive in it that loads a particular format so that each document can formally declare what the format is that it relies on. And I know that there's these comment hacks that work on that, but I'm trying as hard as I can to avoid precompiled formats because I just think they make the world more complicated. And one of the reasons they're complicated is because formats incorporate hyphenation databases, and it makes no sense to me why a hyphenation database should be part of a format. It seems like hyphenation databases should be a separate world. So JSBox can pull in plain.tech in 8/1000th of a second. That includes 50 TFM file parsers. And it reads latex 12,000 lines of TeX, or plus or minus, in about 6/100ths of a second. The idea, though, is because a job is divorced from the interpreter's existence, you should only be able to have to read in the format once and then run a bunch of jobs. That's kind of what TeX does now, but it's much cleaner when you keep the formats out of the interpreter. It's just another initialization level, and if you have namespaces, it may be that formats can be all loaded at once, so that one job could actually dip into plain.tech and then dip into latex and so forth as needed for various services that those formats provide. So I'm not implementing a dump command unless I can help it. So before going on, I'm going to show you a demo. So here is Xcode on my Mac. And okay, I got a different size screen going on here. All right, this is a Cocoa program. It's Objective-C. All of this is in the service of writing a program that I wrote to browse an OpenType font. So let's open Latin Modern Regular. And so I've got this scrolling display. I can change the point size and look at each glyph. I can see the name of the glyph and the number of the glyph, and I can search for glyphs. So this was just because I couldn't stand Apple's font book, and I wrote this pretty quickly. And it shows me a little bit of the metrics, so it shows me the bounding box and so forth. Well, if you notice, the simulated pages I'm scrolling amongst are approximately 8.5 by 11. And that's the actual virtual point size on them. So if you've got a program that shows one glyph on a page, maybe you could modify it pretty simply to show a whole lot of glyphs on a page, especially if you have your own TeX interpreter. It's a library, and here it is right here. There's the inclusion of the library. Takes longer to load this into the editor than it takes to compile it. And this is my style of commenting, which takes syntactic noise and puts it as far away as possible. So this is the code for doing the operator, a primitive that deals with global, long, and outer modifiers. Well, anyway, so let's run this. And before we run it, let's look at see what this file is. So here's TeX Shop. Here's a sample file that, when run, creates a 1,000-page document in the plain format. This takes about 7 seconds, and it creates a PDF file, and then TeX Shop shows the PDF file. And so this has just a famous paragraph in the literature of paragraph line breaking in it. It's got some math, a simple math formula. It's got footnotes of various kinds. I put in an alignment table just to check that out. I've introduced a bug here so that there's a slightly long paragraph, et cetera, et cetera. I've reserved space for some illustrations, but I haven't actually inserted them. And this 1,000 pages go on. And I've also introduced a bug, which you'll notice is the spacing between the display and the paragraph underneath it. So it gets worse and worse, and then it just creates a giant mess. And on page 1,000, up at the top of the page here, after 15,000 footnotes, we get, just a bunch of garbage. Well, okay, so that's what TeX does. Now I'm going to run the exact same file through this interpreter in this Cocoa program. And let's just make sure we start this up. Okay, big story. All right, off we go. And in 2 seconds, I have the exact same document, except there's a couple of slight changes I did. But you can see I'm zooming in. This is not a PDF viewer. I am dipping down directly into the TeX data structures, exporting them on the fly with every single motion of the scrolling. I'm exporting a page to this Cocoa program, which is then using Latin Modern to write the glyphs out, even though I did all the layout using TFM metrics. And you can see, there's this long paragraph. The reason is because I'm not using a ligature right there, whereas if you look at some of the others, there's a ligature which isn't coming out. So this is a very fragile demo. It's not general and so forth, but as you can see, I can go to page 400, and there's the mess that's being created. Let's zoom, let's make this a little smaller. And the mess is getting worse. Let's scroll back to page 1,000 and so forth. Same exact mess. The metrics are, the layout is basically the same, except I introduced a little primitive that allows me to mark a box. Oops. And I can export that box, and I want that to be an illustration. So now I have dynamic illustrations. This is a first-class Cocoa view in this Cocoa program in which I can draw anything I want. So I provide CPU time to that view, and it can draw anything it wants based on that CPU time. This is not a movie. This is an animation that I wrote based on core graphics on the Mac. So I can have illustrations for space-filling curves that are algorithmically compressed. I don't have to worry about PDF in these illustrations. I can have anything that I can display in a Cocoa view in an illustration. So I can have different space-filling curves here. Or when I gave this demo to Don back in November, since he's been working on the Game of Life, I added an illustration to show that you can have a Game of Life running inside your TeX document. But, it doesn't have to be algorithmic. It can be, a TIFF. Okay, so I can look at this TIFF and I can zoom in on it and look at it completely independent of the zooming of this because it's not a PDF file. Notice that I've got controls here. Okay, I can have an entire paint program embedded in this essentially TeX document because this is not a PDF viewer, it's a TeX viewer. In fact, if you have a PDF that's multiple pages, you can embed that. So here's a PDF file that's resolution independent, and it's one of my curves. And I can zoom in on it. The reader can play with the illustration embedded in the very nicely typeset exposition of it, in a page format. And if you've got the ability to look at one PDF, you've got the ability to look at multiple PDFs, because this is just a PDF view. It's all being done by the Mac Toolbox. So now I am embedding the previous document that I made with TeX into this JSBox document. So I can scroll through it. I can look at all 1,000 pages here, and there's all the same mess and so forth. Anyway, so that is the reason I'm working on this, because I need to create an ebook that isn't 600 megabytes of PDF floating point data to sell or to explain everything I know about space-filling curves. So back to, how much time do I have?
15.
Okay. So let's go back to here. So in this interpreter, JSBox, I have implemented so that it completely supports 21-bit Unicode code points internally. I re-implemented all the TeX algorithms and data structures so that they can handle 21-bit Unicode. All input can be a mixed stream. You can have a file of UTF-8 combined with a file of UTF-16. You just declare what the size of the stream is, and it'll unwrap it all into Unicode. And remember, UTF-8 is not really an encoding in the font size. It's a transport format. So everything that comes into this interpreter is converted to full Unicode, And after conversion, then there's the usual TeX mapping, so you can map any of the first 256 code points in the 8-bit plane into any other 21-bit Unicode code point after the fact. So you can still do those fun things, except that the mappings are not compiled in. You can specify them in a job with primitives, or the client can specify what it wants. All strings internally are stored as UTF, and all output to log files or text files is UTF-8, but all output is sluiced through the client. So the client can look at this UTF stream and map it back to anything the client wants. So if you have 1 million Unicode characters, you might be thinking about maybe in the future needing more than 16 possible syntactic category codes for whatever purposes you want to make TeX more useful than it is now. So I've allocated 8 bits for cat codes. The first 16 are the usual. The others, except for one, which I'm going to talk about in a minute, are of course reserved. It doesn't render any current TeX code that I know of unusable, because no TeX code now actually uses a cat code value above 16 that I know of, but I'd like to hear if that's not true. So it's upwardly compatible, and it can be gated by the client as needed. So if the client says, I want you to run as a TeX82 interpreter, it's not going to allow a new cat code to be defined. And obviously the entire TeX community would have to agree on this if we were to move forward with this stuff. Well, if you want to implement namespaces nicely, you need a new syntactic category. No one's proved to me that this is not correct. But so in this interpreter, if you want to use cat code 16 and the proper feature level is set, you can define a namespace separated character. It can be a period or an @ sign or whatever, and the scanner will recognize that and will drill down through nested namespaces to pick out the macro that is defined in that lowest namespace. So you could actually load a namespace for plain, a namespace for LaTeX, etc., and pick off different macros. And it probably won't work for a variety of reasons, but that's because they weren't designed for that. The interpreter will resolve forward or circular references, handle it on the fly. It can actually recompile a macro when it sees that there's an unresolved forward reference that got loaded into the macro as just a bunch of characters following a namespace separated character. So there's ways to solve that problem. And then you can push and pop dictionaries of namespaces just like you can in PostScript. So you can push, and they act like font names. So if you define a namespace with a name, you can say, \LaTeX, then you've got all of the macros in LaTeX, you can use them, and then you just say end namespace, and they've all disappeared. So another problem with TeX is, it gets rid of pages in order to recycle memory. And there's some, things that you can't do when you do that, and, it was great for the time, but memory is almost, you can fit all of Netflix Corporation into a box that size these days. So this library can keep every page in an array that is randomly accessible by the client, and all of that text data structure is the entire tree is there, and it's a lot of memory. I mean, that 1,000-page document used up 200 megabytes of memory. And most of that is, 8-bit pointers, because it's 64-bit pointers in what I just showed you. But memory's cheap, and for a 1,000-page document, that's a reasonable thing. And what you get out of it is incredible. I mean, if you can lay out a 1,000-page document in 2 seconds, you can reflow a 1,000-page document in 2 seconds without even worrying about the stuff that was in the first talk, because all the glue nodes, all the kern nodes, everything is there, and I can export those as well. And if the client wants to listen to that, the client can do that. All right, so the other thing I did, and I spent almost a year of my life on this, is tracing, because I knew that if I'm writing a new TeX interpreter, I have to be able to guarantee that it's working compatibly, and having done my own TeX support, I know that everything I can do to make it obvious and to reveal hidden state is a good thing. So TeX tracing is really second rate. It doesn't trace a lot of things that need to be traced, and of course all hidden state creates confusing modes. That's the definition of a mode, hidden state. Okay, so there's no generic tracing. I have a different execution model in this interpreter than what TeX is. It's parallel to what TeX does, but it's more general. Every primitive traces itself. I use indentation. I assume lines can be arbitrarily long. I use vertical white space to keep the log files from making my eyes glaze over. And I trace all recursive expansion. I trace alignments. I trace where files are not found, etc. And then I've also added some other debugging aids. For instance, I've added a show font command that will dump either an OpenType or TFM font. I've added a debugger primitive that allows me to drop into my IDE's debugger at any point in a piece of text source code, which is a godsend for figuring stuff out. Character data is presented to the user in multiple formats and so forth and so on. When I got through the trip test, which I'll talk about in a minute, I sent a 200-page log file of this trace, which looks like, where is it? I think it's right here. Is that right? I seem to have lost it. Anyway, I sent the log file to Don, and he has told me he believes that I've psyched the trip test out, and he's keeping it in his papers because he doesn't remember what trip.tech does. Whereas this log file actually literally explains almost every little puzzle that he put in there, including some of the most god-awful stuff you can ever imagine. I've also rewritten all the error messages because there's a lot of them that I find hard to understand. I'm a very easily confused person, which is either good or bad, but I think it's good because it makes me, really think about how to write some things in a clear way. So there's no generic error reporters. Every single error message has its own error reporter. And when I first got that badness error, it just confused the heck out of me. I'm sorry, you can't use backslash badness because you're in vertical mode, right? So the first thing you think is, oh, I'm in the wrong mode. So you go, get yourself into horizontal mode, and then you get the error, oh, you can't use badness in horizontal mode. It's like, what, The point is you can't use badness because there's a read-only value and you can't execute it. That's what an error message should say, right? Hell, it's been 30 years now since that error message was written, and it's just, So anyway. It's only a couple of. Yeah. Okay, so error messages can be structured. They can be presented to the client in a structured list so that it can put them all, a certain class in a window, et cetera, et cetera. I don't have two-level errors. I don't refer to the tech book, et cetera, et cetera. So next thing is there's no integral, or if you use ZTech or whatever, and then. So anyway, I got interested in OpenType fonts. Incidentally, I wrote the first Paint program at IBM Research in 1981 for the purpose of editing glyphs on their experimental typesetting equipment. It was a light pen based on a Tektronix terminal, and it would allow you to draw glyphs. So I've been interested in fonts for a long time, even though I haven't worked in them. Anyway, so I've written a parser for OpenType. I've gotten all of it done except for one table. I can dump the entire thing into the log file, which is kind of interesting but useful for debugging. And there's a lot of work. I've got a ton of work. My head's going to explode. I'm not going to try to solve it all generally. I am aware of other libraries. I'm aware of Harfclose. I'm aware of, I've looked at code that parses OpenType fonts. But remember, my goal is to make this system agnostic. So I parse these without calling fseek. And most of it actually is pretty easy to do because it's pretty linear, but then there's parts where you just have to simulate fseek a little bit. But it's very fast.
Probably 5 minutes.
Okay, thanks. So hyphenation databases, I pre-compile the US hyphenation database into the library because I'm, I'm English, I don't know, or American. But it automatically creates the trie from just the it's just strings. It's not actually a data structure. It creates the trie on the fly. So when it reads plain.tech in that 8/1000ths of a second, it's also created the trie for the English database. Anyway, I think they should be dynamically loaded by the library, not by instantiated interpreters. You can have overrides, etc. I keep separate tries for different languages so that you don't have a 256 limit on language codes, and it wastes space, but I don't care about wasting space right now. Fixed point, as everybody knows, TeX dynamic range is half of what you can put in a 32-bit integer so that you can add any two numbers and not worry about overflow, but that doesn't really, that's kind of a hack. And then there's some egregious hacks in the code where he inserts bits into a floating point value so he doesn't have to have an extra argument in a subroutine, and so I've gotten rid of all that stuff. You can recompile this in ILP64 and you'll have a 4816 format, and it'll all be exactly the same mathematics, except there won't be an overflow. overflows saturate, they don't wrap, because that increases the chance of a cascade of errors, which stops the job earlier. And you actually don't need to check for overflow on box content summations except in exceptionally large cases. So it doesn't actually spend any time checking for overflow in box summations unless it's if it can prove that no overflow could ever happen. If it's possible that overflow could have happened, it'll go and actually resum everything. So that's kind of an overview of what I've got. I have run it through the TeX 3 times. It takes me, because all of my log files are completely different from any TeX log files, I have to test them manually for conformity. It takes about 3 days. I've done it 3 times. The last one was about 3 weeks ago, so I could make sure I wasn't lying. All the data structures are basically the same, all of the dumps of data structures. You can look at the log file on my website. It's actually less than 200 pages now because I typeset it slightly different. The library is not ready for prime time. You can't use it. I have not yet eaten my own dog food. That demo I showed you is pretty fragile. I need to understand more about fonts before I can continue. I don't understand how the library, Carl's Path Search library, worked with respect to LaTeX. I think that I don't like it because it is so general that it enables really complicated messes, and I don't like complicated messes. I want things as simple as possible. And so the whole project is a giant struggle between simplicity and generality, but Don wrote me and said, congratulations on a massive achievement, which is kind of nice. And I found no bugs in the source code, but I found a typographic error that he has compensated me before, and I found a bad English sentence, which he has compensated me for. So if no one ever uses this, I will, in my next talk, show you how to typeset the source code, and I'll have a few checks from Don to show to my kids.
Well, my question was going to be, how can I get it?
I don't know. It's going to be a while. I worked on this silently for 5 years because every indication was I was going to fail. But I got to a point where I had, it's like I had to continue, and so I finally told. By the way, my college roommate was the author of BibTeX, so Oren is my second oldest friend. So, I finally told him that I was working on this, and he's like, he had been telling me for years no one was ever going to do this. And so I at least proved him wrong, but I haven't proved Don wrong. But
I'm a little confused. It seems like something was dependent on Cocoa or the Apple display software.
What's the question?
Did your demo actually rely on Cocoa's features?
Yeah, those illustrations are first-class Cocoa views, but those are not part of the tech world. Those are part of the client world. You want to divorce them.
Okay, that's client. Gotcha.
See, I don't think tech is very good at dealing with illustration content. There's always hacks. So I'm a programmer. I want to draw stuff using the best tools I can, and so I want to divorce that. And in my particular case, man, I have no choice.